Beta decay is one of the most important types of radioactive decay in nuclear chemistry. In this process, a nucleus undergoes a transformation by emitting an electron, which we call a beta- particle. This transformation changes the identity of the element itself, converting it into a completely different element on the periodic table. Beta decay is a type of radioactive decay where an unstable nucleus emits an electron, also known as a beta- particle. During this process, the nucleus transforms into a different element. This happens because the atomic structure of the nucleus changes, specifically the number of protons increases. The emitted electron comes directly from the nucleus, not from the electron shells surrounding it. At the heart of beta decay is a fascinating transformation. A neutron, which is one of the particles inside the nucleus, spontaneously converts into a proton. When this conversion happens, an electron is released from the nucleus. This electron is the beta particle that gives beta decay its name. Remember, this is happening inside the nucleus itself, where neutrons and protons reside. The transformation can be represented by a simple equation. A neutron, which we denote as N with a charge of 0, converts into a proton, denoted as P with a positive charge, plus an electron, denoted as E with a negative charge. This equation shows us the fundamental change that occurs during beta decay. The neutron disappears, and in its place, we get a proton that stays in the nucleus and an electron that is ejected. When beta decay occurs, two important nuclear properties are affected. First, the atomic number increases by 1 because we now have one additional proton in the nucleus. Since the atomic number determines which element we have, this means the atom becomes a different element. Second, the mass number stays the same because we started with one neutron and ended with one proton, keeping the total number of nucleons unchanged. The general equation for beta decay can be written using standard nuclear notation. An element X with mass number A and atomic number Z transforms into element Y with the same mass number A, but atomic number Z plus 1, while emitting an electron with mass number 0 and charge -1. This general form applies to all beta decay reactions, regardless of which specific element is undergoing the decay. Let's look at a real-world example using carbon-14, which is famous for radiocarbon dating. Carbon-14 has 6 protons and 8 neutrons. When it undergoes beta decay, it transforms into nitrogen-14, which has 7 protons and 7 neutrons. The mass number stays at 14, but the atomic number increases from 6 to 7, changing carbon into nitrogen. An electron with 0 mass and -1 charge is emitted during this process. Let's review the essential points about beta decay. A neutron inside the nucleus converts into a proton and an electron. The atomic number increases by 1, which means the element moves one position forward on the periodic table. The mass number stays constant because the total number of nucleons remains the same. Finally, the original element transforms into its neighboring element, creating a completely new atom with different chemical properties.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.